Hey everyone. So, if you've ever signed up for a website, posted a comment, or even just submitted a contact form, you've used a really core piece of web technology, probably without even thinking about it. That's the HTTP post method. And today, we're going to pull back the curtain and see exactly how it works. Right? You fill in your details, you click that submit button, and poof, magically, your account is created, your data is saved somewhere. But what is actually happening behind the scenes? What's the mechanism that makes that digital magic work? Well, that's exactly what we're going to break down. So, to really understand what happens when you submit that form, it's actually helpful to first look at what doesn't happen. Now, you're probably familiar with the GET method. It's what your browser uses all day long to just fetch and read web pages. But when you need to send data and actually change something on the server, GET just isn't the right tool for the job. And the difference here is, well, it's everything. Think of GET as being for reading. It's totally safe. It doesn't change a thing on the server. It's also something we call idempotent, which is just a fancy way of saying you can make the same request a million times and you'll always get the same result. Post, on the other hand, is the total opposite. Its whole purpose is to cause a change, to create a side effect. Hitting refresh on a post request could mean accidentally creating 2 or 3 user accounts or posting the same comment over and over again. Big difference. Okay, so if post is all about causing change, then its main job, its number one purpose, is to create new things. This is really the heart of what makes the web interactive, right? It's what allows you to go from being just a consumer of information to an actual contributor. So here's the bottom line. POST is the verb we use when we want to tell a server, hey, take this data I'm sending you and go create something new with it. And that something new is what we call a resource. It could be anything, a new user profile, a blog post, an item you just added to your shopping cart, you name it. And you see this everywhere in the real world. Enrolling a new wizard at Hogwarts? Yep, you're creating a new student resource. Sending a message on a forum? You're literally posting new content. And every time you add something new, like a new user to a database, you're extending a collection. All of these actions are perfect jobs for a post request. So how does the server respond? How does it say, yep, got it, I created that thing you asked for? It sends back this status code, 201. It literally means created. It's the universal sign that your post request was a success and a new resource was born. It's kind of like the server giving you a digital thumbs up. All right, we've got the what and the why down. Now let's get into the how. How did developers actually build a server that can catch and handle these post requests? For this, we're going to look at one of the most popular frameworks out there for Node.js, Express.js. Now, before our server code can even touch the data from a post request, it needs a little help. And that help comes from something called middleware. You can think of it like a helpful assistant that sits between the incoming request and your main logic. Its job is to prepare the request for you, and in our case, that means translating the data into a format our code can actually understand. And the most important assistant for this particular job is Express.json. This is a piece of middleware that's built right into Express, and it's basically a JSON translator. Without it, when a client sends JSON data, our server just sees a bunch of meaningless text. The request.body object, which is where we expect to find our data, will be completely empty or undefined. This one little piece of middleware is what makes the whole conversation possible. So, here's the game plan for our server. It's a pretty straightforward to-do list. First, we hire our middleware translator. Second, we tell the server what address, or URL, to listen to for these post requests. Third, we grab the translated data. Fourth, we use that data to create our new thing. And finally, number 5, we send back that 201 created message to say, job done. A simple 5-step process. All right, enough talk. Theory is great, but seeing the code is what makes it all click. So let's make this real by building a tiny little API for Hogwarts. Our one and only goal, create an endpoint that lets us enroll new wizards. So this is what the client sends us. Maybe it's a web form, maybe it's a mobile app, doesn't matter. It's a neat little package of data, a JSON object, with the details for our new student, Harry Potter. Our server needs to be ready to catch this package and know what to do with it. Okay, let's build this out step by step. First, we create our Express application. And then, the most important part, we tell it to use that Express.json middleware. We're hiring our translator. Now our app is ready for what's coming next. Next up, we define the actual route. This line, app.post, tells our server, hey, I want you to listen for post requests, but only at the /wizards endpoint. This is like putting up a sign that says, new wizard enrollment right this way. Okay, so once a request hits that endpoint, we can finally get our hands on the data. And here it is, the aha moment. Because we set up that middleware, all of the client's JSON has been perfectly parsed and is waiting for us inside rec.body. We just have to reach in and pull out the details we need. Super easy. Now that we have the data, we can build our new wizard object. We'll give it a brand new ID, and then we just push it into our wizards array. Now, for now, this is just a simple array, but in a real app, this is where you talk to a database. And just like that, our new student is officially enrolled.
And finally, to wrap things up, we have to respond. You can't just leave the client hanging. So we send back that 201 created status, and we also include the new wizard object itself as a confirmation. The client now knows for sure that everything worked perfectly. And that's the whole flow.
And this is exactly what the client gets back. It gets that 201 status code, and it gets a JSON object representing the very thing it just asked to create, now complete with its new ID. The circle's complete. The client made a request, and the server not only did the work, but sent back proof. So there we have it. We've built a working, if very simple, API. But how does this little example connect to the massive, complex apps that we use every single day? Let's zoom out and bring it all together. Okay, if you remember nothing else, remember these 5 things. Use post when you want to create something. Express.json is your essential translator. App.post is how you define your endpoints. Rec.body is where you'll find the client's data. And 201 is the status code for success. If you've got these 5 points down, you've totally grasped the fundamentals.
Now, time for a crucial dose of reality. Our wizards array was great for the demo, but if our server were to restart, poof, all our data would be gone forever. In a real-world app, that wizards.pushline would be replaced with a command to save a new record into a real, persistent database, something like PostgreSQL or MongoDB.
And of course, there's always more to it. A production-ready API also needs things like data validation to make sure we're not getting junk data, plus much better error handling, and of course, layers of authentication and security to make sure only the right people can create new things. Our example today is the solid foundation that all of that is built on. So we've totally nailed how to create things with Post, but what about the rest of an application's life? What happens when we need to update a wizard's information? Or in more drastic situations, what if we need to remove them from the school registry entirely? Well, that's going to require some different HTTP methods, and it's the perfect place for us to explore next time.